The question says that PLK equals L to the 0.2 times K to the 0.8. And let me verify that by looking here. Yes, okay. And it wants us to find the maximum L and K, I think. Let us double check it. I am double checking it. Just give me one moment here. I think it says a company is. I'm reading the problem very quickly here. Find the values of L and K which maximize production. Okay, so it is. All right, so to find the values of L and K that maximize production, you're going to need the function they give you, and then you need that constraint function, which is called G of LK. And the words say 10L plus 10K, and then the question wrote an equation that said 10L plus 50K. But I will do, let's see, 10L plus 50K. I'll do 10L 10K, and then you'll know how to do 10L plus 50K. So 10L plus 10K, and it says equals 9,300, but formally it's minus 9,300 equals 0. But you're going to have to put that 9,300 on the other side to solve it. So in order to do this, you're going to use Lagrange multipliers, and you're going to find PL, the derivative of P with respect to L, and you're going to set that equal to some constant, we'll call it lambda, times G of L. And then take P of K, the production function derivative with respect to K, and you're going to equal that times some constant times G derived respect to K, the derivative of G with respect to K. And then you'll use those to solve for that constant, that lambda, and then you can solve that for L or K and plug that back into the constraint to find L and K. So PL equals lambda times GL. That's the derivative of P with respect to L equals some constant times G with derived respect to L, and then P derived with respect to K equals some constant times G, the constraint function with respect to K. So what does it get us? Our production function, derivative with respect to L, is 0.2 times L, and then 0.2 minus 1 is negative 0.8 times K to the 0.8 equals, and then the constraint function derived with respect to L is just 10. Everything else is 0 because they don't have L's in them. Equals 10, and then times that constant, call it lambda. And then P with respect to K is 0.8 K, and then 0.8 minus 1 is negative 0.2 times L to the 0.2. L is just a constant. And then that equals to, again, this constraint function, derivative with respect to K, which is just 10, and then times that constant. So now each one of these you can solve for that constant, that lambda, and you're going to just divide by 10, and then whichever one is negative, has a negative exponent, put that in the denominator and change the exponent to positive. So 0.2 times K to the 0.8. So remember, you can put if something is in the numerator and the exponent is negative, move it to the denominator and make it positive exponent. If it's in the denominator with a negative exponent, move it to the numerator and change the exponent to positive. So divide by 10, and then L to the 0.8. And then this one, lambda, is going to equal all of this divided by 10, and then move K down there and make the exponent positive. So it's going to be 0.8 L to the 0.2 divided by 10K to the 0.2. And that's, we divide it by 10, so that's just lambda equals. Divide it by 10, so lambda equals. And now since both of those equal the same thing, you can set them equal to each other. And I believe I have gone to a second board for that. I have it, and then 0.8 and 10k to the 0.2. Yes. So I set them equal to each other, and you can now cross multiply. 0.2 times 10 is 2. K to the 0.8 times k to the 0.2 is k, equals 10 times 0.8 is 8. L to the 0.8 times L to the 0.2 is just L. So 2k equals 8L. Who knows? We'll solve for k. 8 divided by 2 is 4. K equals 4L. And now we will plug that into the constraint equation. I don't remember which one is first. Equals 10k plus 10L. And it's supposed to be minus 9,300, but equals 9,300, because now I'm going to solve. So k equals 4L. 10 times 4L plus 10L. This is maybe where the 50 came from. Equals 9,300. 40L plus 10L equals 9,300. 50L equals 9,300. L equals 9,300 divided by 50, which is 930 divided by 5. 5 times 1 is 5, 43. 5 times 8 is 40, and a 3. And 5 times 6, so 186. And then k equals 4L. K equals 4 times 186. 4 times 6 is 24. 4 times 8 is 32. Plus 2 is 34. 4 times 4 is 744. So k equals 744. And that's all the question asked. You can find what that maximum production is by plugging those back into that production equation. But there's your answer. K equals 744, L equals 186, using the Cobb-Douglas equation and Lagrange multipliers to find what the numbers are. That's it.